Assalamualaikum, we are from Group Rich Brown and would like to present our TikTok Shop database system.
Assalamualaikum and hi, my name is Nurul Ashikin with matric number A218239. Firstly, I will present the normalized ER diagram of the TikTok Shop database system, which consists of 5 main entities with their own attributes and relationships. As you can see, based on the business rules, one customer can make many orders while each order is made by one customer. An order can contain one or more products through the order detail entity, which acts as a bridge between order and product after the many-to-many relationship was converted into one-to-many relationship. So, one order can have many order details and one product can appear in many order details. Lastly, one seller can supply many products while each product is supplied by only one seller. In conclusion, the normalized ER diagram helps to organize the data properly and reduce redundancy.
Hi and Assalamualaikum. My name is Putri Nurin Farhana and my metric number is A217979. Now I will present about normalization step. First thing first is UNF to 1NF. In UNF, all the order, customer, product and seller information is stored in one table. This can cause repeated data. In 1NF, we make sure each column contains only one value and next, the second one is 1NF to 2NF. In 2NF, we remove partial redundancy by separating the data into different tables. We create 3 tables, which is order details, order and product tables. This can help reduce to duplicate data and makes the database more organized. Next, the last one is 2NF to 3NF. In 3NF, we remove transitive dependency by moving customer information to the customer table and seller information to the seller table. The order table only store customer ID and the product table only store seller ID.
Assalamualaikum and good day everyone. My name is Nur Shazrina binti Kamaruddin, metric number 817543. I'm going to walk you through our database design, which has been structured into 3NF. In the customer table, Cus ID serves as the primary key, uniquely identifying to each buyer and storing their contact details. Similarly, the seller table uses seller ID as its primary key to manage vendor name lists and corporate
Next is the product
table. Each item has a unique product ID. To show who supplies the product without repeating corporate details, we brought in seller ID as a foreign key. This creates a clean link back to the seller. Finally, the order table link transaction to customers using Cus ID as a foreign key. To handle multi-item purchases, order detail act as a bridge using a composite primary key to map out the products and track the total M.
Siti Nafina and my metric number is A218009. In this section, I will explain about data differential language or DDL used in our TikTok Shop database. DDL is used to create and define the database structure. First, we create the database name, which is Rich Brown. Then we create 5 tables, which is customer, seller, orders, product and order details. Each table has primary key to uniquely identify each record. For example, customer ID is the primary key for the customer table, while seller ID, order ID and product ID are the primary key for their respective tables. We also define the appropriate data types such as VACHA for take field, date for order days, and decimal for total amount and price. All the tables successfully, we verified the database structure by displaying the records using select statement to ensure that the tables were created correctly. That's all for our DDL section.
Hi,
Thank
my
you.
name is Dina, metric number 8218194. I will explain about DML. DML is used to retrieve and manipulate data stored in database. For each query, I will briefly explain its purpose and the output. Select statement used to retrieve data from database. Clause specify the table, where clause filter record or joins related table, and order by group by having like a use depending on requirement. SQL1 use the select statement to retrieve the seller name and product name, where clause join the seller and product table using seller ID, assuring the output seller sysgch sell the product massive case. For SQL2, display customer who purchase each product by joining customer order, order detail and product table.
SQL3 display the product supplied by seller S001 by filter the seller ID using where clause. For SQL4 display the product with prices between RM30 and RM100 using between operator. SQL5 display product sold after 10 April 2026 using where clause with date condition. SQL6 display customer whose phone number start with 012 using like operator. SQL7 display product with total amount greater than RM82 using sum function and having clause. SQL8 display product with total amount between RM30 and RM130 using sum function and having clause. For SQL9, display order placed from April to May 2026 using between operator, while SQL10 display product sorted from the highest to the lowest price using order by descending.